Welcome to Math with Mr. Katykhin. Today we're going to be looking at literal equations. One of the things that we should already know is a few definitions that we're going to look at. First one is solving an equation. Again, we've talked about this quite a few times now, but it's when you find the value or values of variable or variables that make the equation true. Inverse operations, which we also looked at when we solved one-step equations, two-step equations, and multi-step equations, which basically does, if we have addition, we can inverse operation by subtraction. Literal equation for today is going to be the definition: an equation with variable coefficients and constants. This basically means that it's literally we're looking at a specific equation, an algebraic expression. So let's go ahead and look at our examples and what we're going to do today. It says solve each equation for a given variable. Now, in our one-step, two-step equations, we only had one variable where we had to solve and figure out what the value of that variable is. Today, we're going to have multiple variables, and we're going to be given a specific variable that we have to get by itself. So starting our first problem, it says A is equal to 1/2 base times the height. That is the equation for a triangle. But notice what it's asking you to do. It says find B. In other words, all I'm doing is I'm trying to get B by itself. Well, to do that, notice I'm multiplying by 1/2, and I'm also both multiplying by h. Well, a couple of things we can do. I'll rewrite this really quickly. We know that if I have a 1/2 base times the height, I can actually get rid of that 1/2 from what we learned previously is by multiplying by its reciprocal. That's how we get rid of a fraction in front of something. So I can actually multiply by 2 ones, which means I can multiply by 2 ones on the other side. Now, as you can see, what happens is the 2 and the 2 simplify to ones, and what you end up getting is 2 times A, which is 2A, or capital A, is equal to base times the height. Now remember, we are solving for B, so the only thing that's keeping B from being all by itself now is this h, and it's being multiplied. So inverse operation of that will be to divide by h. So I'm going to divide by h on both sides. Now notice h divided by h is actually a positive 1. So we get 2 times A divided by h is equal to B. And to rewrite this, I get B is equal to 2 times A divided by h. So my final answer will be B is equal to 2 times A divided by h. Now this is really nice if you're given the area and the height of the triangle and you ask to find the base of that triangle. Well, you would use this equation to figure that out. Go ahead and do the same thing for this next example. We're going to give you a couple of minutes to do that. See if you can solve that same example for h. Hopefully by now you had a chance to solve this on your own, but let's go ahead and look at it together. V is equal to pi r squared times h. This is the volume for a cylinder. So here they're asking find h. In other words, I would circle or highlight my variable I'm solving for. Now, what's keeping that variable from being all by itself? Well, it's being multiplied by pi, and it's being multiplied by r squared. Well, the inverse operations of multiplication would be division. Now I can divide by pi on both sides first, then I can divide by r squared on both sides, or I can actually do both of those with the same step. So if I were to divide both sides by pi r squared, now look what happens. Pi divided by pi becomes 1. R squared divided by r squared becomes 1. So right away we get V, or the volume, divided by pi r squared is equal to h. Now to rewrite this, I get h is equal to volume divided by pi r squared. So now we get those. Now we get an equation that says if we need to find h, and we do have volume and we do have a radius, you already know what pi is. So if we had volume and radius, we would be able to find the height of that cylinder pretty quickly. Let's look at our next example. We have x divided by y plus 3 is equal to b. Now notice what it's asking us to do. Solve for x. So what I would highlight, circle the x in this case, and then I would ask myself, okay, what's keeping the x from being all by itself? This is actually very similar to two-step equation. Notice that we have to do inverse operation of order of operations here. So first thing we have to do is get rid of the minus or additions. Then we're going to get rid of any divisions or multiplications. So starting to get rid of the subtraction or addition, we see that we have minus 3. So that means we have to add 3 to both sides. And if it helps, go ahead and draw a line here. Notice that negative 3 plus 3 would give you a 0. So you're left with x divided by y is equal to b plus 3. Since b is a variable and I'm adding a 3 to it, I cannot combine those, so I have to keep them separate. Now what I would have to do is, again, I'm trying to solve for x. So what's keeping x from being all by itself? That dividing by y. Well, how do you undo division by y? You multiply by y on both sides. Now remember, you're multiplying this whole thing by y on both sides. What's going to happen here is we can put a 1 underneath that. The y and the y simplify to 1s, which actually will give you x is equal to y times b plus 3. You can leave your answer here, or you can go a step further and distribute the y, which I recommend, and you get x is equal to y times b, which will be by, and y times 3 will be positive 3y. And so your final answer is going to be x is equal to by plus 3y. I'm going to give you a couple of minutes to work on the next example. So go ahead and do that right now. So by now, hopefully you had a couple of minutes to work on this example. This example is asking you to find x. So highlight, circle x, and then solve for it. So notice again, we start off by asking ourselves what's keeping x from being all by itself. Well, in this case, you are adding mx to both sides. You also have negative n next to each other. And also notice that this x here is on both variables, the m and the n. Now, if you recall, we just did this step here, where we used distributive property to distribute the y into b and to 3. And we got by plus 3y. Remember, I can do the same thing by undoing the distributive property. And this is where this comes in. So what I need to do here is I need to undo distributive property. In other words, I need to take that x and take it to the front. So undo the distributive property. When I do that, I get x in front. Then what's left is m minus n is equal to p. Now, what's keeping x from being all by itself? Well, x is being multiplied by this grouping. It's being multiplied by m minus n. Well, how do I do multiplication? I divide by m minus n. And I'm going to have to do it to both sides. So m minus n divided by n minus m gives you 1 here. That gives you 1 there. So what you're left with is x is equal to p divided by m minus n. You can leave it like this. If you prefer, you can put parentheses here. But both of those mean the same solution. Alright, let's look at our next example here. So in this example, you see that we have area is equal to 1/2 times height times base 1 plus base 2, and in this case you are asked to solve for base 2. So we have to get that base 2 by itself. Well, before we can do that, we can actually do a couple of things here. So let's start with this following. So again, I recommend getting rid of that 1/2, and that will be simple enough by doing a couple of things. We know that we can get rid of by 1/2 by multiplying by its reciprocal. So let's multiply by 2 divided by 1. But if I do it to the left, I have to do it to the right. So times it by 2 here. So very quickly we see that those simplify to 1, and you get 2 times capital A, or area, is equal to h times b1 plus b2. So from here, to get rid of this parenthesis, I would go ahead and distribute the h, which will give me 2 times a is equal to h times b1 will be base 1 times h, and then plus h times base 2, so it'll be base 2 times h. And remember, don't lose sight, what are you solving for? You're solving for base 2. Well, what's keeping that base 2 from being all by itself? You are adding b1 plus h, and then you're multiplying it by h. Well, since we're solving for b2, we start with opposite of what order of operation is saying. In other words, if we're adding something to it, we need to subtract from it. So we're going to subtract b1 h from both sides. Subtract b1 h from both sides. b1 h, or b sub 1 times h, minus b sub 1 times h, gives you 0. And this, go ahead up here, finish that up. I'll get 2a minus b sub 1 times h is equal to b sub 2 times h. Well, what's keeping, again, don't lose sight what you're solving for. You're solving for b sub 2. What's keeping b sub 2 from being all by itself? You're multiplying it by h. So we're going to go ahead and do the inverse operation of that. Divide by h. Having done that, you'll get the following: 2a minus b sub 1h divided by h is equal to h divided by h is 1, so you get b sub 2. And my final answer will be b sub 2 is equal to 2a minus b sub 1 times h divided by h. So a couple of steps you had to do here to get that specifically solved by itself. Now today's homework, you are actually going to do a lot of these type of problems where you're going to solve for y. So again, ask yourself what's keeping that y from being all by itself. Notice that you are adding 3x and you're multiplying by negative 2. So first thing, we have to get rid of any addition or subtraction. So we do have adding 3x. So we're going to subtract 3x from both sides. When I do that, I get 0 here, and I get negative 2y. Remember that negative or minus is with the 2, not the 3x. And I get 12 minus 3x. Now what's keeping that y from all being by itself? Well, you're multiplying by negative 2. Inverse operation of that will be to divide by negative 2. And remember, I'm dividing by negative 2 on both sides. Well, negative 2 divided by negative 2 is positive 1. You get y is equal to 12 minus 3x divided by negative 2. So you get 12 minus 3x divided by negative 2. And that will be my answer there. Go ahead and try the next two examples on your own. You're solving for y, and then I'll give you a minute to do that. Alright, let's look at what you should have got. Again, we're solving for y, so hopefully you had time to work on these. Again, you're solving for y, so the first thing you should do is highlight or circle y and then start solving for it. So ask yourself, are there any addition to that y? And there is. You add in an x to it, so that means we need to get rid of that x first. So we're going to subtract x from both sides, which then gives you 0 here. And you get 2y is equal to 3 minus x. Now again, don't lose sight of what you're solving for. You're solving for y. So what's keeping that y from being all by itself? You're multiplying by 2. Inverse operation will be to divide by 2 on both sides. So that's exactly what we're going to do. 2 divided by 2 is 1. And you get y is equal to 3 minus x. Divide that by 2, and that will be our solution here. For the other one, again, we're solving for y, so circles, highlight, do whatever you gotta do to get y by itself. So make sure you know what you're solving for. Now notice that on this side where the y is, which is your left side, you have 2 minus 4y. Notice you have a positive 2, so you add in 2 here. So we have to get rid of that 2 first. Now notice when I will get rid of it on the other side, there is a 5, which means I can actually subtract a 2 from that 5. We call those like terms, we know that. So 2 minus 2 is going to be 0, and we get negative 4y is equal to, notice 5 minus 2 is actually 3 minus 3x. Notice I will not be able to subtract 2 from negative 3x because those are not like terms. But because 5 is a constant and a negative 2 is a constant, we can subtract those two. Continuing with the problem, again, don't lose sight. I'm solving for y. So let's go ahead and answer. So what's keeping that y from being all by itself? You're multiplying by negative 4, so inverse operation will be to divide by negative 4, and I have to do it to both sides of the equation. So -4 divided by -4 is +1. You get y is equal to 3 minus 3x, divide that by -4. So let's go ahead and look at this example. It says 2 trains leave Oakland at the same time, traveling in opposite directions. If one train averages 35 miles per hour and the other train averages 55 miles per hour, when will they be exactly 450 miles apart? So in this problem, you have a starting point where both planes take off. So the first plane takes this direction and the other one takes out that direction. Okay, and then it says this plane is traveling, let's say, at 35 miles per hour, and then this plane is traveling at 55 miles per hour. And the question is, when or how long will it take them to be 450 miles apart? So the question is, how long will that take? Well, there's a couple of ways you can do this. I recommend, first of all, we know that when we're talking about how fast something is going, time, that, and distance, there's an equation for that, and we call it r times t is equal to the distance, or some people know it as d is equal to rt. So this is the equation that we're going to use here as well. But in our case, let's go ahead and draw a table which will help us organize our problem a little bit better. So what I like to do is, since we have two things here, I'm going to call this train 1 and that train 2. Now we're using this equation, r times t is equal to the distance. So r represents rate. We know the first train is going 35 miles per hour. We know the second train is going 55 miles per hour. Time, we have no idea. The question is, when will they be exactly 450 miles apart? So that is our unknown. Well, to get distance, we're going to take r times t, okay, is equal to the distance. So take the r, which is 35, times t, which is x in this case, and 35 times x will be 35x. 55 times x will be 55x. Now notice we have 35x and 55x. Now remember, we have to include both of those trains because they're leaving one direction and the other is going the other direction. So they're traveling apart at the same time. So we have to include that. So what we have to say is, since we have this 35x and this 55x, we have to say 35x plus 55x should equal to, remember, the distance of the first train plus the distance of the second train should all equal to 450 miles apart, because that's what we're looking at. That's what we're trying to figure out. When are they 450 apart? And so we have to take the first distance plus the second distance. Now looking at that, you can see that we can combine like terms. We have our x's. So in our case, we have 35 plus 55. Well, that gives us 90x is equal to 450. Again, to get x by itself, since it's being multiplied by 90, we're going to divide by 90 on both sides. So divide by 90 on both sides. 90 divided by 90 gives you a 1. So our x is equal to, well, the zeros can simplify to ones, and then you get 45 divided by 9, which is 5. Now remember what x is. X is time. So time is given in hours. So what this means that both of those trains will be 450 miles apart in 5 hours. So in 5 hours, both of those trains will be 450 miles apart. Go ahead and try the next example. It's very similar, except now you're using buses rather than trains. So go ahead and see if you can figure that one out. Use the chart, and then I'll go over this problem in a minute. Hopefully you had an opportunity to do this problem, but let's go ahead and do this together. It says 2 buses leave Los Angeles at the same time, traveling in opposite directions. The first bus is traveling at 10 miles per hour, faster than the second bus. After 3 hours, the buses are 345 miles apart. How fast is each bus traveling? Well, similar problem, but again, what you should have started with is the chart. This will help us understand this a little bit better. In each case, notice we're going to be using the same exact equation. So in each case, it's going to be rate times the time is equal to the distance. So bus 1, and you got bus 2. So let's go ahead and fill in the things we know. It says the first bus is traveling 10 miles per hour faster than the second. So 10 miles per hour faster than the second bus. So what this is saying is that if the second bus is some speed, then the first one is 10 times faster, which means it's plus 10. So let's call the first bus R speed. We don't know what that is, but we know it's some kind of rate. Well, if that's the case, then the first bus is going 10 miles faster. So let's go ahead and put R plus 10. Now, it says after 3 hours. Notice both buses after 3 hours, which means T is 3 here and T is 3 there. Well, how do I find my distance? Well, my distance is going to be rate times the time. So in this case, it would be 3 times R plus 10. And then this distance would be 3 times R, which is 3R. So now we have to solve this problem. It says after 3 hours, the buses are 345 miles apart. Remember, it's the first distance plus the second distance. So I have the first distance, which is 3 times R plus 10, plus the second distance, which is 3R, is equal to, how far are they apart? 345. So looking at that problem, you should have noticed that we need to go ahead and distribute the 3. So 3 times R is 3R, plus 3 times 10 will be 30, plus 3R is equal to 345. Notice in this problem we do have like terms. So the 3R plus 3R gives us 6R plus 30 is equal to 345. Now let's go ahead and solve for R to find out what the rate is. So in our case, we need to subtract 30 from both sides first. That will give you 0, and you get 6r is equal to, well, 345 minus 30 will be 315. So now to get r by itself, we have to take 300, or 315 in our case, and divide that by 6. So, but remember, we have to divide by 6 on both sides. So divide that by 6, divide that by 6, and we get r. Since 6 does not go evenly, we would actually get 52.5. In other words, 52.5. So what does r represent? Well, r represents the rate, how fast something is going. So this would be 52.5 miles per hour. But look what the question asked. It says, how fast is each bus traveling? Well, the r that we found is actually the r, or the rate, for bus number 2. So bus 2 is going 52.5 miles per hour. However, bus 1, remember from the problem, is going 10 miles faster. Well, 52.5 plus 10 will actually be 62.5 miles per hour. So my answers should be bus 1 is going 62.5 miles per hour, and bus 2 is going 52.5 miles per hour. And that concludes our lesson plan for today. And then also remember, you have a worksheet that is called Solving for Y.